On this video, I want to show a practical example of using BGP communities. We have 4 routers, 2 OpenBGPD and 2 Cisco. Each one has its own autonomous system. AS1 advertises route 1.1.1.0/24 and route 2.2.2/32. AS4 advertises route 3.3.3.0/24 and route 4.4.4.4/32. To make things clear, I will name route 1, route 2, route 3 and route 4. The goal is AS1 advertise to AS4 route 1 with the preferred path through AS2 and route 2 through AS3. On the AS4 side, route 3 through AS2 and route 4 through AS3. I could do this easily with AS path prepend. For example, on AS1, to advertise route 1, I will prepend my own autonomous system number on the link through AS3. So, as 4 will receive a path to 1 with 2 hops from AS2 and with 3 hops through AS3. But if, for example, AS2 prepend 2, on this situation AS4 may choose the path through AS3 that AS1 cannot control. To avoid this kind of problems and others related to AS path prepend, there is the RFC 1998, an application of the BGP community attribute in multi-home routing. This RFC is a recommendation and acts the following way. I send a community with the number of the autonomous system that I want to influence and the value of the local preference that I want to set on that link to reach my autonomous system. For example, in our scenario, in AS1 for route 1, I send a community value of 4:90 through AS3. 4 is autonomous system that I want to influence and the 90 the local preference. When it reaches AS4, this will set a value of the local preference to 90 on the link. As the default value of local preference is 100, it will choose the path through AS2. Let's see how to do it. The simple command on OpenBGPD tells neighbor in AS3 to send this community value for route 1. AS3 permits the transit of the community attribute with neighbor send community command. And on AS4, there is a route map that matches this community and sets the local preference. On the way back for route 3, I have this route map that sets the community value of 1:70 when it matches the ACL 101 that match address and mask of route 3. Take note that I am using the new format representation of the community value to better see the autonomous system number that I want to influence. Then, on AS1, these 3 commands check the community that is receiving from all neighbors and sets local preference accordingly. Let's go to the command line. Here we see the configuration in AS1. Take note that I am denying my own AS. The purpose of this is to make the same behavior as Cisco for loop prevention. We can test this by commenting this line. Need to reload, wait a moment. And now we see our own AS number in the path. Let's put back the original configuration. Going back to the configuration, I am sending for AS2 this community value for prefix of route2. We can see from this output that our policies are taking place. Route 3 is preferred through AS2 and Route 4 through AS3. You can see the local preference value of each one. And on AS4, Route 1 is best through AS2 and Route 2 through AS3. Let's check the configuration. A little more complex than OpenBGPD because of the route maps concept, but the results are the same. This route map AS2 matches the prefix list 4 that matches Route 4 and sets this local preference value. This route map is then applied to the neighbor on AS2. Let's make a test. On AS2 we prepend 3 times on the link through AS4. We need to wait. Now on AS4, even with the AS path longer, we choose this path to Route 1 because of the precedence of local preference in the BGP decision process. Local preference attribute is not transitive between autonomous systems, but communitized, so this simple method is a great help in multi-home routing. Thanks for watching.